right, as we get started today, I want to begin by reviewing our 3 different graphing methods. So if you go back in your mind a couple of weeks when I first introduced graphing to you, the first graphing method that frankly we don't really want to use very often at all was graphing by anyone? Think back on graphing by table, the XY table. So let's go ahead and do this first equation together. X minus 4y equals 5. We're going to graph this equation, but we're going to do it by the table method. So let's see if we can remember how to do that. It's the most basic method, though it's also the slowest. Brecken, the first thing in order to graph this equation by table would be to get get a variable or a letter, if you want to go really generic, right? Get a letter by itself, either one, right? Now, that's not the case for slope-intercept form, right? It has to be the y by itself. With the table method, either one can be by itself. And Brecken, which one would you rather get by itself? All right, so we're going to rewrite the equation then. All right, and once we've got one of the letters by itself, then, Maddie, we were supposed to set up the table itself, right? The XY table. Of course, we want to make sure we put X in the first column, Y in the second column. And we've got to ask ourselves, which letter are we actually plugging in values for, Noah?
Y.
How do you know it's the Y?
Because it's in the other side.
It's not by itself, right? It's the independent variable if you're wanting to use technical terms, or it's not by itself, right? We're solving for the X, not for the Y. And normally I like to pick which values for my Y. 0, 1, and 2. And so if I plug in a 0 class, I'm going to get X equals 5. 5 plus 4 times 0, 5 plus 0. If I were to plug in a 1 right here class, I would get 9. I could probably fit a 9 on my graph, probably. If I put a 2 right here class, I would get 13. I almost never can fit that on my graph, so let's not use that. Well, what's another Y value I could use then? Gavin?
-1.
Maybe a -1. Okay, now be careful here. If we were to plug in a -1 right here, then when we multiply class, we would get -4. Class plus 5 would be 1. And these are values we could graph, right? So go ahead and set up a Cartesian plane on your graph paper. And let's go ahead and graph this equation together. Again, that's one of the drawbacks to graphing by this method, is all of the plugging in values and making sure you do your math correctly. If you mess something up, you're in trouble. And the fact that there are some values you try to plug them in and say, oh, but I can't really fit that on the graph. And there's a little bit of annoyance, perhaps, at times with this method. Nonetheless, good to remember it. And we'll just plot our 3 points. 5, 0. 9, 1, and 1, -1. Yes, sir.
Got a pen and pencil.
Do you want to rent, buy, or take it to marry?
Rent.
Rent?
Yes.
All right. Do you have 25 cents?
I have $1.
For $1, you can have 4 pencils. Or I can make change. After class. All right. There's a very slight upward slope, slight positive slope on this equation here. All right, questions on graphing by table? Any questions graphing by table? Been a little while since we've done it. Want to make sure we didn't forget how to do it. That said, any of you actually feel like you'll use this method if you have the choice? I don't ever choose this method. Now, the next method's not bad. The next method we talked about, Brecken, we called the and we remember, anyone help him remember method number 2? Gavin?
Intercept.
The intercept method, okay? And the key with the intercept method, coming back to Brecken, is with the intercept method, we simply wanted to find both the x and y intercepts. The nice thing about intercepts is you just plug in zeros, right? So when finding the x-intercept, we just have to plug in a 0 for the, and when we find the y-intercept, we just plug a 0 in for x. So coming to this equation here, if we wanted to graph this by the intercept method, well, when we plug a 0 in for the y, this term would drop out. What's my x-intercept bracket? Good, -9/2. And then for the y-intercept, Maddie, 0, 3. Now, we say -9/2, and there's nothing wrong with saying it, but as far as graphing it, we actually need to think what, Noah? -9/2. Like, where do I even graph that?
3 and
Oh, Noah. 2 goes into 9
4,
with,
1 half,
so,
4 and 1 half,
negative
-4.
-4.5. So we're going to come back into 1, -2, -3, -4, -4.5. And then we've also got our y-intercept at 3. The key to remember is 1's an x-intercept, so it needs to be on the x-axis. 1's a y-intercept, it needs to be on the y-axis. And once we've got those, we can connect the dots. And that's a good review of our second graphing method. Our final graphing method is my personal favorite. This is the one I will use most of the time, especially if the equation looks like this, because that equation, class, is already in this is already in slope-intercept form. Okay, that's a Friday. We're struggling today. Class, this equation's already in slope-intercept form. What is slope-intercept form, class? Okay, now can we do it without looking at the poster? Class, what is slope-intercept form? Ah, so that means that the -3/5 is in the place of what letter? M. And the -1 is in the place of what letter? B. What is M, class? Slope. What is B, class? The y-intercept. Which of these two things, the slope or the y-intercept, do I take care of first, Maddie? So I'm going to start with the y-intercept at -1. Again, that needs to be on the y-axis. It is a y-intercept. And then from that point, Noah, I should
go up 3.
Okay.
And back 5.
And once I've plotted that point, I simply connect the dots. And we get our line. Questions on these graphing methods? 3 methods. You can choose whichever ones you want normally. Unless the directions specifically tell you, most of the time on quizzes, tests now, I'll just say do whatever you want with it. But questions on these 3 graphing methods. Now, in addition to talking about slope as far as, positive slopes and negative slopes, and class, vertical line would be undefined slope. Horizontal line, class, would be 0 slope or no slope. We talked about how to find slope. If I gave you just 2 points without graphing them, how we could find the slope. What is that slope formula, Maddie? Good, this is a formula. It is what you use to calculate something, right? Your formulas your whole life, whether it be a Celsius formula, a perimeter formula, an area formula. Like you remember all these formulas in math class. Formula was always used to find something. This is a formula. You use it to find slope. Slope-intercept form is a format. It's a layout. It's the way something looks for an equation. This is our formula for slope. So let's suppose I gave you a point. Let's just call it A. And point A is -3/8. Suppose I gave you a point B, and I told you point B is -1, -2. Instead of plotting them and connecting the dots, I simply want you to find the slope of AB. Notice the way this is set up, lowercase m for slope, and a capital AB as subnotation or subscript kind of like the subscript we see here, means the slope of line AB. At your seats, find the slope of line AB using the slope formula. Key to remember, make sure your y values go on top. Either y value can lead off. It doesn't matter. Noah, you could pick -2. All right. But once he's picked that first y value, he has to subtract 8. And he has to start in the denominator with minus. And anytime we see minus in negative class, of course, we know we're just going to make that a positive. In the numerator, be careful, we have -2, -8 class, -10. In the denominator, we have -1, +3 now class, +2. So what is our slope, class? -5. How many had a slope of -5 or -5/1? All right, questions on that? Let me give you a couple more points. Suppose we had a point D is 4, 1. Suppose we had a point E is -3, 2. And I wanted you to find the slope of DE at your seats. Find the slope of DE there at your seats. How did you set up your numerator here, Brecken? And so the denominator had to be? And I gave you? But we're going to slide the negative. And there we go. -1/7 or -1 to 7. How many got that slope for the second one, DE? Excellent. Turn your books to page 109. Let's take a look at your homework. We were practicing getting slope-intercept form. Again, what we practiced earlier with slope-intercept form was already there. It's already nice, neatly in slope-intercept form, no trouble at all, no work at all. Plot the y-intercept, rise and run, you're done. Well, connect the dots and you're done. And but it's not always quite that easy. And so there are times we have to get the equation into slope-intercept form. That's what you were practicing with last night. On page 109, you did numbers 28 through 33. You should have graphed them on 2 different graph grids, 3 equations graphed per grid. So let's take a look at those. That's 28, 29, 30. All right, and then 31, 32, 33. All right, there's the work. Where's the graphs? That's an empty sheet of graph paper. Give you a moment to find it. And did you label which one was which? Might have been helpful, like number on next to the line, which one was which, or do different colors or something like that. Might have really helped. Just a suggestion. All right, like Gavin did. Well, you did 2 blues and, but at least it narrows it down somewhat. 2 blues and a gray. All right, so let's go ahead and take a look at the equations we had. Number 28 said 2y minus 4 equals 3x. And for number 28, walk me through what we did very quickly, Gavin.
I moved the -4 over a +4.
To get?
2y equals 3x +4.
Then?
Then I divided away the 2 on
To get?
everything to get y equals 3 over 2x +2.
All right, so then when it came time to graph, you plotted your
+2
as your
y
y-intercept, right? All right, and then from there you,
went up 3
okay?
and then moved to the right 2.
All right. plotted that point, and should have connected the dots to get a line that looked like this. How many had a line like this for number 28? Maddie? Do you have a line like that at all? Went the other way. Okay, so careful, no negative here. The 4 even becomes a positive, so be careful with that. Number 29, we had an 8x minus 2y equals 10. Now, there is a little bit of a strategy here I want to show you. You ready? Shortcuts. I love shortcuts. Notice every number here is even. If you wanted to, you could knock a 2 out of everything right up front. 4x minus y equals 5. After all, that's essentially what you do here when you divide everything by 2. Why not just knock it out early? Get it over with. Just a thought. I don't know how much time it really saves, but I love simplifying equations. Just a thought to throw out there. Anyway, let's suppose we had done that. What would we do from here, Noah, to finish getting the y by itself? 2 ways to do it. You chose, or you would choose.
Double swap.
Double swap to get.
4x negative 5 equals 1.
Good, but instead of equals y over here, we'll say equals y over here. And now we can clearly see our y-intercept should be at.
Negative 5.
So here's negative 3, negative 6, and negative 5 be right here. Then from there we need to
Go over.
and then run
1.
the understood 1. It's not written. You don't have to write it. It may help you to write it so that you can see that it's there. And there's our equation for number 29. How many had that line for number 29? Probably didn't do it this way, but had that line. Does it make sense this way? Okay. You could do that with any number, right? For instance, if I saw a 15x plus 6y is equal to 21, does anyone see what number I could knock out of everything?
3.
I could knock a 3 out of everything. It just makes my life a little easier, okay? So I love knocking numbers out and simplifying stuff because I'm lazy and I like easy numbers to work with. Number 30. We had a 3x plus y equals 6. Oh, hey, here we go. Could I knock a 3 out of everything, class? No. There's not a number with a 3 in it here. This should be really easy to get the y by itself, Maddie. Just? To get? All right, and then we're ready to graph. We put a on the y-axis as our y-intercept. Good, and then from there? And then, which way? Backward 1 or left 1. Good. And so this would be our equation for number 30. How many had an equation like that for number 30? All right, question, Brecken.
On the graph, I'll put positive 1, not negative 1.
Okay, you had the negative 3 here. You just ran the wrong way. Okay, questions on that? Let's take a look at number 31. We had a 5x, negative 2y is equal to 10. And let's see here, Noah, walk us through this one.
You divide everything by 2.
Can I easily? Now, so let's save it for later. If I can do it easily, like everything just knocks out evenly, cleanly, that's when I'll do it up front. Let's save it for later, though we will eventually have to do it anyway. What might we do next?
Double swap.
Okay, you're a double swap back to the core. All right, so what do we get?
5x negative 10 equals 4.
All right, and then we do have to,
Divide everything by 2.
right, so when we divide away the 2 from everything, let's move this to this side now. We get
Y equals 5 over 2x negative 5.
There we go. Again, it's not so much that I'm moving it over, because it's not joining this. It's just kind of flipping the whole thing around, almost like you're looking at it from the other side of the chalkboard, which is why we don't need to change signs. It's not actually moving it to this side to join it. It's just kind of flipping it around. And so to graph it, we need to put our
Negative 5.
as our,
Y-intercept.
and then from there, rise,
5.
run it forward,
2.
and should get a line right about here. Now, you would not have had this line on the same graph with the other dotted line, but notice it looks pretty similar to the last one. How many had a line like that on the second graph grid? All right, number 32, x plus 3y equals 9. And let's see, Brecken, walk me through this one.
Take the x over as a negative.
Okay,
3y equals
Okay? All right, then we need 2. Good. Good. Excellent. Up 1, but he didn't say the 1, but he knew it was there, and should have gotten a line something like that there on our second graph. Did we get a line like that? All right, and then our last one for the homework was number 33. 2x minus 3y equals negative 12. And again, I look at this and I see both 2 and 3 can divide out of 12. Intercept method probably is the easiest, right? Like plug in a 0 for y, 6, or negative 6. Plug in a 0 for x, positive 4. Man, it's so easy, okay? Where, like this, same kind of thing. Here, I can't divide the 10 by the 8 and the 2. Here, it's not, maybe not easy to divide, but something like this, intercept method may actually be easier. That said, we were using slope-intercept form. So, Maddie, walk us through. Okay. Good, it's not a 3, it is a negative 3, unless you had first changed all the signs. But dividing by a negative 3 is going to change all the signs to get. There we go. And of course, we'll plot our y-intercept class at the for class. We will rise and run forward 3. And we get a line, something along those lines. All right, questions on this? Do you feel like we got slope-intercept form down to a science? Turn over to page 113 now, page 113. I want you to look at the very bottom of the page, the last 3 problems on page 113. And we did these yesterday, this exercise where you did a little bit of mind reading. And on these 3 problems, they've given you a slope, they've given you a y-intercept. They want you to think of what equation would have that slope and that y-intercept. Very quickly, you can do it right there in your books, at the bottom of the page, or in your notebooks if you prefer. Number 7, 8, and 9, very quickly. This should take about 30 seconds. If you know the slope and you know the y-intercept, then you know the equation. Write it. 7, 8, 9, 5 on page 113. Good, Noah's done, Brecken's done, Maddie's done, and Gavin's done. Number 7, what is the equation, Gavin?
Y equals 1/2 x negative 3.
Good, y equals a half x negative 3. Number 8, Maddie. Good, y equals negative 4x plus 3. And number 9, Noah.
Y equals 2/3 x positive 2.
Good, y equals 2/3 x plus 2. Did we get all 3 of those correct? All right, excellent. So that brings us then to what I told you we're going to do today, and that's find equations of lines. Now, if you knew the slope, class, and you knew the y-intercept, it's super easy, right? So we're going to look at, well, what if you don't know those things? Next section of your notes. Finding the equation of a line. Finding the equation of a line given a point and the slope. Finding the equation of a line given a point and the slope. Finding the equation of a line given a point and the slope. All right. So, for instance, we know this. If I told you that the slope of a line is 4, that's 4 over 1. That means up 4 and over 1. We're going to get a line that looks something like this, right? But there's literally an infinite number of lines that could have that slant. They'd all be parallel, right? But there's an infinite number of lines with that slant. If I told you that we have a line that passes through the point 2, 5. Well, you know this. If I just put a dot on the board, there's an infinite number of lines I could draw through that point, right? But through a particular point, with a particular slant, there's only one line, correct? And the question is, what's the equation of that line? Here's the thing I want you to keep in mind. Just a second ago, you found the equation of a line because you knew what 2 things? Slope and y-intercept. What are the two things we must know to know the equation of a line? Slope and y-intercept. So, I know the slope, I don't know the y-intercept, correct? Do you realize then that the key to this process is find the y-intercept and you good? That's really all it comes down to. What in the world is the y-intercept? Step number one, start by writing out y equals mx plus b. Start by writing out y equals mx plus b. Now this is a step students love to skip. And you know me, I'm lazy, I love skipping steps too. I have found skipping this stupidly easy step messes students up, okay? So it seems so stupid easy, but start by actually writing out y equals mx plus b. The reason, this will focus your mind. Do you realize b is the target? If I can find b, then I know m, I know b, and everybody's happy, I'm done, right? Here's the deal. If you know the slope, then I know that m can be replaced with a 4. The question is, what do I replace y and x with? Well, you have a point, right? That's a set of coordinates, right? That's an abscissa, or that's an x and a y. So what do you think I'm going to put where it says y class? 5, because that's y. And in for x, I should probably put 2. Step number 2 is substitute m, x, and y. Step number 2 is substitute or plug in m, x, and y. Seems pretty easy, right? Plug in m, x, and y. Now look at what we've got. We've got a little tiny equation, and there's only one letter. If I get it by itself, I've solved for b. Let's multiply to get, and then ditch the 8 to the other side as a negative 8. Makes sense? It's an 8. Move it over as a negative 8. And apparently b, all alone now, is equal class to negative 3. Step 3 is solve for b. Step 3, solve for b. Because remember, what two things did I say I needed to know? M and b. Slope and y-intercept. Guess what I know? Slope and y-intercept. I am thinking of an equation. The slope is 4. The y-intercept is negative 3. What is the equation, class?
Y equals 4 x is positive b. Negative 3.
Y equals 4x negative 3, right? Y equals slope x, y-intercept, right? That's all there is to it. So the final step is to rewrite with m and b. Rewrite with m and b, because those are the two things you need. You need m and b. Y equals mx plus b, m and b. That's what I got to know. Once you know them, you're done. You got the equation. Let's do another one. Suppose I want to find the equation of a line with a slope of 2 and passing through the point negative 1, 3. So I've got a line that goes through negative 1, 3. It has a slope of 2. The first thing we want to do, class, is focus our mind by just writing out. I think you know. Class, we want to start by just writing out.
Y equals mx plus b.
Correct. Pathetic, but correct. Okay. So what we're going to do now is we're going to plug in everything we know. I know a particular y value I can use, Matt. 3. I know the m I'm supposed to use. Brecken? 2. And I know the x I should use, Gavin. Obviously, the only thing I don't know, class, is b. So we're going to find it. We're going to do the next step more or less in our head. We're going to multiply, class, negative 2, and we're going to move it to the other side as a positive 2. Multiply, then move it. I think we can do both of those in our head just fine. Giving us b equals, class, 5. Now, word of caution, because I know how smart people are, because I is one of them. Don't have good grammar, but I is one of them. All right, we're going to be like, I know that's a negative 2. I'm going to have the positive 2. I'm going to do 5, and I'm not going to write it right here. Can't tell you how many people forget to change the sign when they try to do it all in your head. So I would recommend showing the moved value. Again, they're just little things you can do to avoid mistakes. I like going fast, but I'm obsessed with accuracy because I hate getting wrong answers because I hate getting points off, okay? So go ahead and show this step of, I know it's a -2 becomes a +2. That way you don't screw up. It forces you again to think of that. Well, there's slope. There's y-intercept. Noah, what's the equation?
Y equals 2x plus 1.
There we go. Easy enough. Feel like we got the hang of this? Maddie did nod her head. Let's do one more for Maddie. Let's suppose we have a slope of -5/2. Well, there's something really evil to Maddie. And suppose this particular line goes through, I can't write a TH, through the point 2, 1. Maddie, I want to figure out what equation, what line, what linear equation has that slope goes through that point. Start with. Maddie's just resolved to nod her head more often. And over like a bobblehead now. All right, in for the y value I plug in. Equals. In for the x. And here's a strategy tip, class. It is not uncommon for slope to be a fraction, right? Slope's normally a fraction. If it is, write your x value as a fraction. So instead of just writing 2, Maddie, we should write 2/1. What that's going to allow you to do is it's going to allow you to better multiply these fractions here. And of course, we don't know the b. Now, Maddie, it's very convenient this time that this 2 and that 2 can. That won't always be the case, but to be quite transparent, often it'll be the case. You know, as long as you don't tick me off. You know, and then I rewrite the test with really nasty fractions and stuff. But as long as you're, you know, kind to the math teacher and give donations of money and gifts and candy, then you know, you should get pretty easy numbers. Okay, I'm kidding. Anyway, I think. All right, so when we multiply here, we cancel in the multiplication process. This whole thing just becomes Maddie. But I'm going to move it over to the other side as a, so what is b, Maddie? 6. I know b, I know m. Maddie, what's the equation? There are not 2. There's only one m.
Yeah,
-5/2. X. Plus 6. There we go. And that's it. Y equals -5/2 x plus 6. Do we feel like we got it now? All right, we got a nod that time. All right. Page 113 at the top of the page now. Do numbers 2, 4, and 6. Page 113 at the top of the page now. Watch your numbers 2, 4, and 6. Find the equations of these lines. When you finish number 2, check your answer. Once you finish that first one, check your answer, make sure you're on the right track. If not, fix it. If you are, go on to the next two. Any questions on number 2, first of all? How many had it correct? Noah, figured some things out. Okay, you didn't do it. Remember I told you you're going to screw it up. This is a -3, and you knew that. Show moving it as a +3. Again, if you'll write that moved that value, you're not going to screw up. But again, I told you, I've seen it for 11 years. Students who don't show that step, just it's hard mentally to remember to multiply and move and change signs. So yeah, show that little step. This is fun. Number 4. 5/2. Pretty ghastly, right? There's a couple ways you can approach this. You know you have to move it over class as a -5/2, right? But this is a 2/1. You could multiply top and bottom by 2 to make this a +4/2, -5/2, get you -1/2. That's one option. Did I copy something wrong?
Yeah, it was -5.
Oh, thank you. -5/2, +5/2 to get you +9/2. Try that. Okay, that's one option. The other option would be once you get to this point, go ahead and multiply everything by the LCD. Right? It's what we always do with equations that have fractions. Multiply everything class by a 2 to get 4. We multiply this by 2, -5. But don't forget this also has to be multiplied by 2 to get, or not to be. And then we're going to move the -5 over as a +5 to get 9 equals 2b. And when you divide away the 2, there's your 9/2. Does that make sense? Now, since I'm not actually graphing this, I don't care about 4.5. I'm going to leave 9/2. There's my m, there's my b. Y equals a 1/2x +9/2. So 2 ways to approach it. If it does happen to stay a fraction, you could set this over 1 and get your common denominator. Or just multiply by the LCD and knock the fraction out and get your fraction at the end. How many think, after our work with fractions, common denominator is no problem for me? How many say, I think just getting rid of the fraction in the first place is easier for me? You choose what's best for you. As we look at number 6, you're all happy to see there's not a fraction in the slope spot. That's happy. All right, and so how many are done with number 6? Are we all finished? Everyone finished number 6? You're finishing up over there, Gavin. All right, so in for the y, 0. In for the m, -3. In for the x was a 2. -3 times 2 class. But move it over as a, to get b equals 6. And so we have y equals, it was a -3 slope from earlier, x, +6 for the b. And there's our equation on number 6. And then we get 2, 4, 6 all correct. You got all of them. How many got 2 out of 3 correct? You just missed 1. How many of you was number 4 that we missed? All right. Let's take a look at another one of these before I go on to my next assignment. Let's go look at another one that involves a fractional slope. Let's suppose we have a slope of, pick a fraction for me, Noah.
1/2.
1/2? Let's pick a different one than 1/2. We just did 1/2. 1/4. Okay, I thought you were going to say 1/3. All right, 1/4. And let's suppose we have this line going through the point, I don't know, 5, -6, or something really random like that. All right, for starters class, we begin by writing out, then Brecken, we write all right, and obviously nothing is canceling here, right? That was the big issue with number 4, is that nothing canceled away. So what is 1/4 times 5/1, class? 5/4, right? By the way, this is why we do the fraction chapter before this chapter. Remember we went crazy out of order? There's a reason for it. Come on, Rebecca. Anyway, but anyway, they didn't consult me in the writing of the book. And by the time I gave them my feedback, they'd already written the book and printed it, and they weren't printing another one. All right, anyway, so we got 2 options now. Option number 1, just knock out the fractions class, multiply everything by 4. Option number 2 is go ahead and bring the 5/4 over as a negative 5/4. But then we're going to have to multiply top and bottom by 4. So instead of -6/1, we're going to get -24/4. -24/4, -5/4, class B must be -29/4. Again, the other option would have been, let you compare and see which one you like better, multiply everything by 4 to get what, Noah?
24 equals 4 plus 4b.
This was a -6, I'm sorry, so -24. Bring the 5 over as a?
Negative
To get
29.
-29 equals 4b. And then we divide both sides by 4 to still get 29/4. Okay? You choose which of those methods you would use. Make sense? All right, do 1, 3, and 5. Do the even problems, now let's do some odd ones. Yeah, it's like they're all odd. almost done. Maddie's done. Just about got it too. All right, number one. What'd you get for your answer bracket? Good. Y equals 2x negative 3. Number 3, what did you get, Gavin?
Y equals 3x negative 13.
Good. Y equals 3x negative 13. And number 5, this was the hard one. Noah, what'd you get?
Y equals negative 2 over 3x positive 5 over 3.
What was the end part?
Positive y and 1/3.
Positive y and 1/3?
5.
5 and 1/3. Okay, or 16/3. Again, if I'm not graphing it, I don't care about the mixed number. I'm too lazy to do that. Yeah, y equals negative 2/3 x positive 16/3, but I will take positive 5 and 1/3. All right, how many had all 3 correct, first of all? All right, you two, you did not. All right, which ones did we miss? Anyone miss number 1 and need to see it worked? Number 3, need to see it worked. Okay, number 5, need to see it worked. So only number 3. Number 3 was our hard one? Is that correct? Okay. On number 3, we're starting with y equals mx plus b. Check your work. Plug in the negative 1 for y. Plug in the 3 for m. Plug in the 4 for x plus b. 3 times 4, class? 12, but it moves over as a negative 12, and that's where we get negative 13. So y equals slope of 3x, negative 13. Move it over as the negative. All right, so everyone got number 5. Is that correct? Oh, you meant 5. Okay. All right. So we start with y equals mx plus b. Because number 3 was the third one in your mind. I got you. Okay. I was like, how did you? Okay, we're good. We're good. At least it makes sense. We have a valid excuse anyway. That's half the battle. We're going to write the x value, which is 5, as 5 over 1 plus b, which gives us 2 equals negative 10/3 plus b. Now, bracket, here you've got a choice. Either clear the fraction out or move it over and turn this into a fraction with the denominator 3. Which do you do? You just get the fractions out of there. Okay, so multiply everything by. Well, okay, maybe that's part of the problem. I don't really care about the negative. I just care about the denominator itself. I just care about the 3. So let's make our lives easier because I'm lazy. And I get. Now, again, I've got to move the negative 10 over as a. And I need to write that step so that I get 16 instead of like a 4 or a negative 4 in this case. All right, equals 3b, and then when I divide away the 3, that's where I get that 16/3. All right, questions on these? All right, tonight for homework, you're going to do kind of a variety of exercises over the weekend. So a good variety this evening / over the weekend, depending on when you do your homework. I would encourage you to do it today during study hall while things are still fresh in your mind. Page 114. Page 114. You're going to do number 17 and 19. Then put a slash. 23 and 24, you're going to graph those on the same graph grid, the same Cartesian plane. 17 and 19 aren't graphs. So 17 and 19, not graphing. 23, 24, you're graphing together. 27, 28, you're going to graph together. And then 31, 33, 37 are not graphs. 31, 33, 37 are not graphs. So again, 17, 19, 23, 24, 27, 28, 31, 33, 37. Where 23, 24 should be together on a graph, and 27, 28 should be together on a graph. There's your homework. We'll take a look at it Monday when we come back. Have a wonderful rest of your day and a great weekend. You are dismissed.